Hello and welcome to CEB. Before starting the video, if you have not subscribed my channel, do subscribe it, like the video and share the video. Today we will discuss safety algorithm for single instance of resource. Now what is a single instance of resource? For example, we are having printer in our system. So that is going to consider as a single instance. Now how many resources are present in our system? So that we are going to first calculate. So how we are going to calculate the total number of printer, the total number of resources in our system. So that is by using the formula total allocated two processes, total allocated resources to your processes and the available resources. So what is total number of allocated resources? Here we are having two process P0, 4 to process P1 and 6 to process P2 plus the available resource. So here the available resource is 2. So what will be the total count? 2 plus 4 plus 6 plus 2 will be 14. So where we are going to use it, we are going to use whether our question is correct or not at the end. Now we will start with the need matrix. The first step for calculating, for finding the safe sequence is to start with the need matrix. So we are going to calculate the need matrix. Okay, so how we are going to, what is the formula for need matrix? The need matrix formula is max minus allocated. Okay, so what will be the need of process P0? 4 minus 2 will be, the need will be of your process P0 will be 2. 8 minus 4, it will be 4. And for process P2, it will be 12 minus 6, that will be 6. So that is our need matrix. Okay, so 2, 4, 6. Now we'll start with the second step is that we will take each need and we will compare with the work. Now what is your work? Work is nothing but the available. So this will be treated as your work. Your available is treated as your work. Now what is the next step is we will take the need of individual processes. What is the need of process 0? Let us start with process P0, whether it is less than equal to work or not. So what is the need of process P0? It is 2, where process P0 requires 2 printer, and in our system we are having total available resources is 2. So we can give 2 printer to process P0. Now what the process P0 will do, after using the 2 printers, it's going to release its already allocated printers. So because of that, what will be the total number of resources that will be available at that time will be work is equal to work plus allocated, that was previously allocated to P0, that is going to be released. So here the work that is the number of printer available is 2, and at that time how many resources were all allocated to process P0? It was 2. So that will be added here. So what will be answer? The answer will be nothing but the total number of printer available in our system. Now we have to write the safe sequence. The safe sequence is that we have selected P0. Now after P0 has completed its task, is going to release the resource and is going to terminate. Now who is remaining in our queue? Only process P1 and P2. P1 requires 4 printer and P2 requires 6 printer, whose need will be satisfied. As P1 need is less than equal to work, we can jump for process P1. So here we are going to write that formula, need of process P1 whether it is less than equal to work. So here the need of process P1 is 4 is less than equal to 4. So this condition is satisfied. That means now we are going to add P1 in our safe sequence. So now after completion of the task, what the process P1 is going to do is going to release its resources to the system. So the current new work will be current work plus the resources that was allocated to process P1. So the current previous work was 4 plus the resources, the printer that was allocated to P1. How many resources, how many printer were allocated to process P1 at that time was 4. So the total number of resources that were released to your system now is 8. That means we are having 8 printer in our hand. With the 8 printer who is remaining in the queue, P2 is remaining. Can I satisfy the need of 6 with the 8 available resources? Yes, the need can be satisfied, and we are going to write this formula. Need of 2 is less than equal to work. So the need of 2 is 6 is less than equal to work. This condition is satisfied, and now P2 is also going to be added in our save sequence. So P2 is added. Now next step will be, after this thing, after giving 6 resources, 6 printer to process P2, what the process P2 is going to do is going to release its allocated resources. So because of that, the new work will be your current work, current available resources, plus the resources that were allocated to process P2. So current available resources is 8, and how many resources were allocated to process P2 at that time? We have given 6 printer to process P2. So that we are going to add to 8. So 6 plus 8 is nothing but 14 now. That means after the termination of process P0, P1, P2, now we are having 14 printers in our system. So that means this value should match to the value that we had already calculated in the beginning, that how many printers should be there in the system after your calculation. So this value is matching. If the value is matching, that means your calculation is done, and you have created a proper save sequence for your question. So this is how we are going to find out the save sequence for the system, and we can answer whether the system is in the safe state or not. Thank you for watching. If you like the video, share the video, subscribe the channel, and do comment if you are having any kind of problem. Thank you.